Have you ever thought about this question? In reversed phase chromatography, does an earlier elution always mean the compound has higher polarity? Or rather, is retention time determined solely by the compound's polarity? Before we dive into that question, let's first understand what polarity actually is. When two atoms form a covalent bond, the difference in electronegativity causes the electron cloud to shift toward one side, leading to a separation between the centers of positive and negative charges. The same happens in more complex molecules. They can develop a permanent dipole moment, which gives rise to molecular polarity. Polar molecules, having these permanent dipoles, interact through dipole-dipole interactions when they come close to each other. These interactions give rise to what we know as like dissolves like. But why do some non-polar substances also dissolve in polar ones, such as benzene and ethanol? Benzene is a non-polar molecule, yet in the polar solvent ethanol, the electric field of ethanol can induce a dipole moment in the benzene molecule. This is called an induced dipole moment. This induced dipole can then interact with the permanent dipole of the polar molecules, forming what we call an induced dipole-dipole interaction. Now let's take a look at cyclohexane. It's a molecule with very low polarity. If we replace the hydrogens on the ring with hydroxyl groups, it becomes inositol, still symmetrical. However, the hydroxyl groups can easily form hydrogen bonds with water, making inositol highly soluble in water, and shows an earlier elution in RPLC, clearly contradicting the idea that higher polarity, earlier elution. In this case, retention time depends both on polarity and hydrogen bonding. In most cases, when we discuss retention time, we still focus on polarity first. That's because many analytes naturally contain functional groups capable of forming hydrogen bonds, such as hydroxyl groups. For structurally similar homologous compounds, the number of hydrogen bonds they can form is usually the same. The main differences lie in the number of methyl, methylene, alkyl, or double bond groups. When analyzing their elution orders, polarity remains the primary factor to consider. In chromatographic separation, there are many factors that can affect retention time, including polarity, hydrogen bonding, pH, and pKa. However, in most cases, polarity is still the main factor we consider, since it plays the dominant role in explaining both a compound's water solubility and its elution behavior, accounting for more than half of the overall influence, followed by hydrogen bonding. That said, no matter how we quantify these factors, we should remember, when analyzing chromatographic peaks, polarity alone is not enough to explain everything. If you like these insights, feel free to share a like and subscribe.